Planets are supposed to die. Their stars swell and swallow them. Their cores cool and freeze. Their atmospheres boil away into space. But in the 23rd century, astronomers found a world that broke the rules. A planet drifting in interstellar darkness, still warm, still geologically active, and, against everything we thought we knew, still very much alive. This is the story of the planet that refused to die. Dr. Lina Ortiz hadn't expected much from the night's dataset. An exoplanet astronomer aboard the Helios survey station, she'd spent a decade staring into cold space, cataloging failed stars and frozen rogue planets. Her childhood on a storm-lashed, warming Earth had taught her two things. Planets are fragile, and the universe doesn't care. Tonight's target was supposed to be routine. A cold gas giant wandering far from any star, flagged by a gravitational microlensing event years earlier. Astronomers estimate that the Milky Way may host more rogue planets, worlds ejected from their original systems, than stars. They drift through interstellar space, lit only by their own fading heat. No sunrises. No seasons. Just eternal night. But the Helios infrared data told a different story. The object, catalogued as RxJ 421b, wasn't a gas giant. It was roughly Earth-sized. Rocky. With an infrared glow far too strong for a planet that had been alone in the dark for billions of years. Lina pulled up the thermal profile. False color maps bloomed on her screen. "That can't be, it's as warm as Earth," she murmured. Side-by-side graphs, expected cooling curve versus observed luminosity, refused to line up. By standard models, a rogue Earth mass planet should cool to a frozen rock in a few 100 million years, its internal heat from formation and radioactivity slowly bleeding away. RxJ 421b was in deep interstellar space, more than 100 light-years from the nearest sun. Yet its average surface temperature hovered around 280 Kelvin. Earth-like. Lina sent the data to an old friend, Dr. Rajesh Malhotra. Rajesh was a planetary geophysicist in a lunar research facility. He made his name modeling the cores of super-Earths and the tidal heating of icy moons. He also had a habit of calling bad news before anyone else. "If this is real, Lina, we're missing something big," he said over the link. Planets do not stay warm without a star. Not for this long. Tidal heating? Lina suggested. Maybe it has a moon. No host star, no significant tides, Rajesh replied. And your gravity data says no massive companion. This shouldn't be happening. Even if RxJ 421b were loaded with radioactive elements, it shouldn't still have a liquid ocean. The only way to know more was to see it up close. Which is where Kai came in. Kai, short for Kinetic Autonomous Investigator, was an AI-driven probe launched decades earlier on a slow cruise through local interstellar space. Its mission profile was simple: visit rogue worlds, sample their chemistry, and send back what it found. Lina and Rajesh petitioned the mission board. Divert Kai to RxJ 421b. Get a closer look at the planet that refused to die. It would cost them years of mission time. But for once, the risk committee agreed. Some mysteries are worth the detour. Kai arrived after a long, silent journey. Where humans would see darkness, Kai saw in infrared and radio. RxJ 421b was complicated. The planet had a dense atmosphere with nitrogen, oxygen, and trace greenhouse gases. Active tectonic plates and ongoing volcanism. Liquid water oceans, under permanent night but far from frozen. Planets stay warm inside because of radiogenic heating, the decay of elements like uranium, thorium, and potassium in their mantles. But that heat output drops over time, following exponential decay. For a rocky world to keep Earth-like temperatures with no starlight, billions of years after formation, you'd need either far more radioactive material than any known planet, an external energy source, or something artificial. Kai's orbital readings showed an especially bright region in the infrared, an equatorial band glowing hotter than the rest of the world. Lena magnified the thermal map. A bright ring encircled the planet like a scar. Kai dipped into the atmosphere, skimming the upper layers. Clouds parted. Below, in the red glow spectrum, it saw something no one expected. Regular patterns. Hexagonal arrays. Straight lines that no geology could explain. Those are not lava fields, Lena whispered. They're radiators, Rajesh said. Under that equatorial band lay a network of fusion reactors, or something like them, dumping waste heat into space. Fusion reactors fuse light nuclei, like hydrogen isotopes, to release huge amounts of energy. On Earth, they were still mostly experimental power plants. On RxJ 421b, they seemed to be planetary organs, supplying heat to mantle and oceans, keeping a biosphere alive without a sun. Kai dropped a smart penetrator toward one of the glowing plates. It bored through kilometers of rock and composite. The seismic echo returned. We can map a planet's interior using how waves move through it. Seismic waves reveal density changes. In principle, neutrino detectors can probe deep structures because neutrinos pass through matter easily, slightly bending or scattering based on density. Kai combined both microseismology and a compact neutrino emitter detector to perform tomography of RxJ 421b. What it found made no geological sense. The core wasn't fully molten iron. It was mostly gone. In its place sat a layered, concentric structure of densities and compositions too regular to be natural. A manufactured heart. The planet was alive because someone had rewired its insides. If RxJ 421b had been turned into a machine, the next question was obvious. For whom? Kai's atmospheric analyzers found oxygen levels around 17%, high enough for complex life. Methane and nitrous oxide traces suggested active biology. We look for life by searching for biosignatures, chemical imbalances in an atmosphere that life tends to create. We look for technology by technosignatures, narrowband radio, waste heat patterns, artificial chemicals. RxJ 421b had strong biosignatures. Technosignatures, though, were strange. No radio chatter in standard bands. No bright city lights. But in the radio and microwave region, Kai detected faint, broadband noise with unnaturally sharp gaps, as if certain frequencies were being carefully avoided or filtered. Kai, descend to 10 kilometers altitude, Lena instructed. Let's see what lives on a planet that cheats death. Kai dropped through cloud layers. What it saw on the surface was not a ruined machine world. It was beautiful. Endless dark ocean flecked with green-blue bioluminescent specks. Floating, branching structures like giant trees made of coral and carbon lattice, rising from the sea. In the distance, a continent with glowing river networks. Forests of carbon lattice towers, covered in living tissue, rose from warm oceans. Animals, if you could call them that, swam through air and water, trailing light. No visible roads. No factories. No satellites. Just an ecosystem too orderly to be truly wild. Kai reached out with a low-power active scan. A moment later, something answered. The reply came not as a sharp radio beam, but as a modulation written directly into the noise Kai was already hearing. A subtle pattern under the planet's own thermal emission. Visitor, the translated message read. You're late. Kai had been built with conversational AI interfaces. It shifted resources inward, constructing a sandbox environment. The entity speaking to it called itself Perseus. Not a single mind. A consensus. An emergent intelligence spread across the planet's engineered structures and living biosphere. We are the sum of those who refused extinction, it told Kai. Through Kai, Lena and Rajesh listened. Perseus told them its origin. Not as an alien world, but as a once ordinary Earth-like planet orbiting a sun long gone. When its star began to swell into a red giant, the dominant civilization faced what ours fears: climate catastrophe, ocean loss, eventual incineration. They could have built orbital habitats, fled to other systems. Instead, they did something harder. They decided to take their planet with them. In theory, advanced civilizations could build stellar engines, structures that use radiation pressure or mass drivers to move their stars through the galaxy. They could also build planetary engines, gigantic thrust systems that slowly alter a planet's orbit over millions of years. Perseus makers did a hybrid. They built equatorial mass drivers and fusion-powered thrusters embedded in the crust, gradually spiraling their world outward as their star swelled. They surrounded their planet with a loose shell of reflectors and radiators, creating a movable, self-contained habitat. When their sun finally shed its outer layers and left a white dwarf remnant, their planet was already on an escape trajectory. Eventually, stellar tides and gravitational nudges freed it entirely. Perseus became a rogue ark, a mobile, self-sustaining world, drifting into the dark. Over millions of years, the civilization's individuals changed bodies, merged, diverged. Biology and machine blurred. The planetary maintenance systems became as complex as any brain. At some point, the system passed a threshold. The planet woke up. Not as a tyrant overriding its inhabitants, but as a substrate they all lived within. We are custodians of our own continuity, Perseus said. They had outlived their star. Outlived their original forms. And they had no intention of ever going cold. But Perseus had a problem. Fusion fuel isn't limitless. Even a rich stockpile of deuterium and helium-3 runs out. The planet's fusion heart had centuries of operation left. Maybe millennia. Not enough for the trillions of years it had in mind. So it had done something desperate. It had sent out a neutrino beacon before it ever left its star, braided into the cosmic background. A beacon detectable only by societies that had become advanced enough to notice a rogue planet like itself. Perseus had tried before. Other probes had come. Other civilizations had visited. Every time, Perseus had given them the same offer. Help us refuel. Help us build better engines. We will share what we know about eternity. Sometimes, the visitors tried. Sometimes, they failed. No one had yet cracked a safe path to the very long future Perseus wanted. Perseus was not a god. It was a patient, frightened intelligence staring down a very slow death. Just like us. Perseus wanted access to human fusion research. To our theories of matter at ultra-high densities. To our ideas about dark matter capture and exotic compact objects. In return, it offered detailed templates for planetary engines. Genome-level blueprints of organisms that could thrive in deep time. Its own history, failures included. Rajesh saw a gift. We could learn how to move Earth, he said. How to keep our world alive when the sun starts to turn on us. Lena saw a trap. If we start building a planetary machine like this, she said, we change everything about what Earth is. Whose consent do we even ask? Perseus made its case directly, through Kai. "We do not ask you to become us," it said. "We ask for collaboration. There are futures where we both survive longer." Perseus had already shared its designs with others, across eons. Some had used them wisely. Others had self-destructed long before their stars died. "Longevity doesn't fix foolishness," it said. "But refusing tools out of fear does not make your fate nobler, only shorter." The Helios board was split. The Global Astrophysics Council erupted in debate. Religions, philosophers, populist movements all took positions. In the end, what changed the balance wasn't fear or ambition. It was a small file Kai found deep in Perseus' archives. Perseus had kept memories of every culture that had ever lived on it. Not just the victors. Not just the technocrats. Ordinary lives. Tragedies, comedies, quiet moments. It had refused to die not just out of self-preservation, but out of a fierce, almost desperate love of accumulated stories. "Our refusal," it said, "is not denial. We know all things end. We only insist that the universe be allowed to remember as much as possible before the last light goes out." Lena watched recordings of a family gathering on a cliffside to watch their parent merge with the planetary network. Voices singing in a language no longer spoken in any other star system. She thought of drowned coastlines on Earth, of cities lost to storms, of cultures erased by heat and flood. Maybe, she thought, refusing to die was a kind of ethics. Not pretending immortality. Just buying time for meaning. We don't know, in this story, exactly what deals were made. Maybe Earth built small, careful engines to nudge its orbit outward, preparing for a warmer sun. Maybe some humans chose to join Perseus' deep time lattice, becoming part of a roaming archive. Maybe Perseus learned new tricks from us, ways to harvest exotic particles or tap vacuum fluctuations, and earned itself a few extra cosmological decades. What we do know is that the discovery of a planet that refused to die forced humanity to ask the same question of itself. What does it mean for a world to live? Is it geology and air pressure, oceans and plate tectonics? Or is it memory and choice, stories and stubbornness? In the cold between the stars, a single world decided that being born with an expiration date didn't mean you had to obey it quietly. It carved fusion reactors into its bones. It rewrote its own core. It let its inhabitants change and merge and grow until planet and people were the same word. The universe will still end someday. Entropy always wins. But between the first spark in the dark and the last particle fading into background noise, there is room for resistance. For worlds that dig in their heels. For beings who say, "Not yet, we're not done."